we're going to, in 7.7, you're going to learn about the graphs of the secant, cosecant, and then the tangent and cotangent. We'll focus mostly on secant and cosecant here tonight. So the first thing I want to do is just show you how to do this on your calculator, okay? Now, all of these things are in radians, okay? And that's because there's no degree symbol on this. Now, what you do on something like this is you would want to make sure, first of all, that you're in radian mode when you do that. And how would you put a secant in your calculator? You don't have a secant button. What do? 1 over cosine, right? Because remember, we learned that the secant's just 1 over cosine of 0.42, like that. So you would put that in like that, and we'll just round it to like 4 decimals. Okay, so we'll do that. 1 over cosine 0.42, and that will give about 1.0952 if you round that off like that. How would you do a cotangent? 1 over tangent. Okay, so we got 1 over tangent of 2.94, and again, you want to be in radian mode, so you just do it like that. So that's one of the reasons why you got to know which things are reciprocals of each other. So that one is going to be a negative number. So that's negative 4.8931. Okay, the reason that turned out to be negative is because 2.94 is kind of close to pi. Pi is 3.14, and pi radians is 180 degrees. So that's actually like a quadrant 2 angle in radians. And the tangent and cotangent are both negative in quadrant 2. That's why that happened, okay? How would you do a cosecant? You do 1 over sine 3.66 like that. What quadrant do you think 3.66 radians is in? It's bigger than pi. Pi is 3.14, so where is it? 3, right? Halfway around the circle, and then a touch more. So what kind of answer do you get when you do a sine of a quadrant 3 angle? Negative. Okay? Remember, sine is positive up there, sine's negative down there. Okay? It's good to know those things because a lot of times it's easy to make a mistake on your calculator, and a lot of times students just kind of take whatever comes out of the calculator and just take it as the answer. So you want to make sense of your answer. Okay, so what that's going to be then is about negative 2.018, and then that would be 2 like that. Okay? So that's all you do, okay? Go ahead, if you got your calculator, you can press in the next 2 real quick and just make sure we're all on track with how to do that. So we got 1 over cosine of 0.31 for the next one. And I'll round that again to 4 decimals, so that's going to be 1.0501. You got to be careful about your rounding. And then the next one, you would go 1 over sine. Then you would go 5.24. And let's see, that would be negative angle, okay? Negative 1.574 like that. 2 pi, the whole way around the circle is about 6.28. So that's going to be below the x-axis. That's why it's a negative answer. Okay, does that make any sense? Okay, you want to try to make sense of these things when they come out on the calculator, whether they're negative or positive. That's important. Okay. Okay, now we're going to get into the graphing. Okay, so this will be something kind of new. We're going to learn how to do a cosecant graph. Okay, now to begin with, what we're going to do, if you do a cosecant graph, the first thing you want to do is you want to do the graph of the sine, which we've learned how to do. Okay, so when you do a sine on the unit circle, remember you're looking at the y value. So I'm going to quickly fill out this chart for the sine. Okay, so notice that if we have the sine of 0 radians is going to be 0. Sine of pi over 2 is going to be 1, like we've learned. Sine of pi is back to 0. Sine of 3 pi over 2 is negative 1. And then sine of 2 pi is back to 0. Those are your 5 key points on a sine wave like that. If you do them backwards and start looking at it that way, negative pi over 2 would be negative 1. Negative pi would be clockwise, so that's 0. Negative 3 pi over 2 would be there, so that's 1. And then negative 2 pi is clockwise like that, so you're back to 0. So what I'm doing is I'm doing 2 cycles, okay? What is the period of the sine? What did we say? Have you got that down yet? 2 pi, good. We have 2 periods. See, that's a period right there. From 0 to 2 pi is 1 period. That's the second one there. It just repeats itself. That's the idea. Okay? Now, what you want to do on this now is you want to go ahead and fill out the next row for the cosecant. The cosecant is just the reciprocal of the sine, right? Okay? So what we're going to do is take the reciprocal of each of these numbers. 1 over 0, what do you know about that? It's undefined. Okay, let's just put like an undefined there. Okay, that's going to mean something. Then we do the reciprocal of 1, which is still 1. Then we go 1 over 0. So that's undefined like that. So what you're going to notice on this is everywhere the sign is 0, the cosecant's going to be undefined. And that means something in our graph that we'll talk about. So you can go ahead and just put these as undefined like that. And then the rest of them you can do in your head. The reciprocal of -1 is still -1. The reciprocal of 1 is 1. And so forth like that. Does that make sense what I just did? Okay, cosecant's reciprocal of sine, so that's where you get that information. And you got some things that are undefined. Okay? All right, so what I'm going to do next, we'll go to the next page and we'll do a graph. So is there any questions about the table of values and where I'm getting that information? Everybody good with that? Okay. All right, now let's do a graph. Okay, so what I'm going to do on the next page is we're gonna go ahead and hold on. We need to do a graph here. I just didn't give you guys an axis. So let's go ahead and do a graph on this. And what you want to do is let's just draw a x and y axis like this. Okay, then we'll get everything kind of put together. Now what we're going to do on this is you want to label your x-axis in radians. You never ever label your axis in degrees in this class. So you always go by radians, and you'll get this memorized pretty soon if you don't already have it memorized. So you want to get that set up, and then you want to do the negative ones as well. So I'm just following what's on my chart. Okay, like that. And what we're going to do is I'm going to have you go up to 1 and down to -1, kind of like that. Okay? All right. So let's go ahead and let's graph the sine. Now the way you want to do this, you guys want to get this memorized as soon as possible. The sine starts there, right? Then it hits the high point, then it cycles through those 5 key points. So when you're doing a basic sine, you want to just have that memorized because you're going to do it all the time. So we start there, and then we just start cycling through the points that we learned on the sine, and then I'll kind of do that in a dashed line before we do the cosecant. And then we kind of move through these other points like this. And then I'm going to label that as, that's the graph of y equals sine x. Okay, so that's what we've already learned. Okay? All right. Now, what we want to do on this is, if you look at the table we did, these places right here is where you're undefined. If the sine is 0 and you do the reciprocal of 0, you get undefined, right? So all of those x-intercepts, what you're going to have is you're going to have what you call a vertical asymptote. You guys probably learned about vertical asymptotes in college algebra, possibly. Okay? You're going to deal with those in here too. So here's what you want to do. Everywhere the sine had a y value of 0, you want to just take a vertical asymptote and draw that through like this. Okay, on all those points. And when you do asymptotes, do like a dashed line. It's not a part of the graph, but it's an important instrument to get the graph, so it goes like that. Okay? So what we've done so far on this is we got the sine, which we learned how to graph, in the last section, and then we get the asymptotes. The asymptotes, the way you want to learn the asymptotes too, is they are what you call the midpoints. The midpoint is halfway between the max and the min, so all of those things right there are midpoints. You don't want to think of it as x-intercepts, because if you had an up-down transformation, then you're still looking at the midpoints as where those asymptotes are. Okay, now here's how it goes. I'm just going to show you how the cosecant graph goes, and then you just sketch it in. So what you do is if you look at this max, it's just kind of a U shape, and what it'll do is it'll approach the asymptotes. It won't touch the asymptote, but it'll just get infinitely close to it like that. On the minimum, you do a U shape, but that's going to be going down, kind of like that, so that's how that goes. And then the same thing over here you would have that. Okay, and I'll show you something on the calculator that'll help you maybe understand this. So let me just show this. You don't need to do this on the calculator, but just to help you with this, if I did a number barely bigger than 0, okay, like if I do the cosecant, remember I do 1 over sine. So I'm going to take a number that's just barely bigger than 0, like say, let me put one extra 0 in there, like 0.01, like that. Okay, I'm doing the cosecant, right? 1 over the sine. Now look what happens. You get a really big number. So what that's saying is if you're just barely bigger than 0, that number gets bigger and bigger. Does that make sense? Okay, anytime you have a vertical asymptote, the graph either goes to infinity or it goes to negative infinity. Here's another thing I want to show you. I'm going to do 1 divided by sine, and I'm going to take a number slightly smaller than pi. Let's see, pi is 3.14, so let's do 3.13. Look what happens. Okay, you get another number that's bigger, that gets bigger and bigger like that. So when you're around an asymptote, that's what happens. Either positive infinity, negative infinity. Does that make any sense to you guys? Okay, so that's how your graph goes. When you do a cosecant, all you're going to do is graph the sine, graph the asymptotes, and you're going to sketch the U-shapes in. I don't care about the accuracy, I care about the shape. Okay, does that make sense to everybody? Okay, because once you get that sine, you're going to have everything that you need. Okay, so we're going to look at a couple of things on this now. So I want to go through and show you a few things with this graph. And I'm going to try to kind of zoom on this so you can see the graph as I do this, okay? Now, one of the things that sometimes students struggle with a little bit in this section is writing the domain the correct way, and then writing the equation, the asymptotes. So I'm going to show you how I do this. What I'm going to do is just write down every place where there was a vertical asymptote. Okay, because one of the things you got to learn how to do is you got to learn to look for patterns. Okay, the domain, what you learned in college algebra is what is a domain? It means what are you looking for? X values. It's what X can be. If you look at the graph that we just did, X can be everything except it's undefined at an asymptote. So it's all real numbers except where there's an asymptote. But you don't write it that way. You have to write it as a formula, so pay attention to this. Okay? So what you're going to do on this is this has a pattern, and it's an easy pattern. What do you predict comes after 2 pi? 3 pi, 4 pi, 5 pi, 6 pi, right? What kind of numbers do you call 1, 2, 3, negative 1, negative 2? We have a name for those numbers. What are they? Integers. Okay, you need to know that. Integers are numbers that are on a number line, no decimals or no fractions. So if you don't know that, write a note to yourself. Integers go like this. Whole numbers, negative or positive, including 0, like that. So what we do is we say this. We say that number in front of pi, I'm going to use the variable k, and that's going to be an integer. So what we say on the domain is we just write this way. We say set of x. Let me zoom on this a little bit. So we say set of x such that, and then all you got to do is say x is not equal to k pi, and then you got to say k is an integer. Okay, like that. That's the simplest way to write the domain, is like that. So it's an integer pi. There's going to be times when it's going to be even number pi or odd number pi, but the point on this is the number in front of pi is an integer. Does everybody understand that okay? Okay, you understand that okay? All right. So you use that variable k to represent that. All right. So that's how you have to write the domain, is like that. Now you don't have to say it's all real numbers. You can just, when you say x is not equal to k pi, you're telling me that it's everything except those things. Does that make sense? Okay, so you've got to write formulas. Okay. All right. Now let's continue to answer these questions because this is pretty important. Okay, look at my graph. Does the cosecant graph have a minimum or a maximum just by looking at it? No, the U shape gets high forever, right? And it gets lower and lower, so it doesn't have anything. Okay, don't confuse that with the sine, so we don't have one. So it has no minimum and it has no maximum. Okay, like that. Okay, so it goes like that. Okay, range. What did you learn in college algebra? Range is. What do you look for? You look for y. What's the y ranging from? That y value is 1, and then it's bigger, right? So you would say 1 to infinity. And then what do you have? Less than negative 1. So you'd say negative infinity to negative 1. Okay, so you got to write that either in an interval or in a inequality like this. So you would write this like this. If you did it in an interval, you would say negative infinity to negative 1. And then you would say union. You got to have a union symbol to join those. Then you start at 1, and then you go to infinity like that. Okay, you guys okay over there? You got a question or something? Okay, everything good? Okay, so you can write it this way, or you can write it this way. You could also say set of y such that y is less than or equal to negative 1, or y is greater than or equal to 1 like that. And you need to be flexible, guys. You can't just learn how to do interval without set build. You got to know both. Okay, yes?
So I was taught to write it with interval notation, that you write negative infinity to negative 1, and then you do union with the brackets negative 1, 1, and then you do union 1.
Now that's not what the range would be on this graph, because the negative 1 to 1 is, you don't have a graph there. I'm only looking at the blue part right here. Okay. So what you're doing, you're right, you'll sometimes see intervals that will be between something. Right. But what we're doing is the cosecant graph, so that would be the 1 infinity, and that would be the negative infinity, negative 1. Okay. So you don't have a graph between negative 1 and 1 because that's the sine graph. You see what I mean? Yeah. Okay. But you're right, you're saying the interval the right way. Okay. It's just that missing part is not a part of the range. Okay. Okay, let's see, the period on this one, okay? Well, if you look at the graph, okay, what's changed? What do you have? You have a U that's going up like that, and you got one that's going down like that. That's a period right there. So what is the distance from here to here? 2 pi. Okay, so every time 2 pi goes by, you'll have a U going up and a U going down over and over and over again. And the other thing you'll have is 3 asymptotes. 1, 2, 3. An asymptote's always halfway in the middle of a cosecant. Okay, so that's how that goes. So what we're going to say on that then is the period's 2 pi. Okay, now be careful about the amplitude. When you look at the amplitude, the formula for the amplitude is half the distance between the max and min. Okay, does this cosecant have a maximum? No. Does it have a minimum? No. So therefore it doesn't have an amplitude. The only time you have an amplitude would be a sine or cosine, when you have a minimum and you have a maximum. That's it. Okay, so that means on this one you don't have one. All right. All right, so that takes us through that. Now the next thing is the vertical asymptotes. You're going to do this. This sometimes is a problem area for students. You have to write this as an equation. First of all, anytime you have a vertical line, you have to say x equals. Like for instance, how do you graph x equals 2? You go straight up and down through x equals 2. So what you have to do on this is, it's kind of like the domain, you have to write an equation. Your asymptotes go like this. If you look at this equation, it would be, you have x equals 0, x equals 1 pi, x equals 2 pi, and then from there you would have what? 3 pi, 4 pi, 5 pi. So how would you write that as a formula? X equals k pi, and what kind of number is k? It's an integer again, okay, like that. So you write this like this, you say x is equal to k pi, and then you say k is an integer. Now I'm going to show you a symbolism if you've never learned this. You have to say k is an integer, but if you want to abbreviate it, you can write it like this if you want to. Maybe some of you have learned that before. That funky looking z is a symbol for integer, and that funky looking e is epsilon. That means it's a member of that set. So if you want to learn to do that, you can. You can either just say x equals k pi, where k is an integer, or you can learn to do that. You'll see me doing that all the time. So it's good to just learn that abbreviation. Has anybody seen that before? Maybe? Okay, just kind of depends. Okay, so let's see. The equation of the vertical asymptotes, I don't know why I have that on there twice, but that's just the same thing. We talked about why the graph got infinitely big, and the main reason for that is If you do 1 divided by a number close to 0, that usually goes to infinity. So as you get close to an asymptote, then it just means the graph either goes to infinity or negative infinity like that. Okay? Now, this thing right here I'm not going to talk about much yet, but it's an important thing. When you find the equation of an asymptote, sometimes it's easy to see the pattern. A lot of times it's not. So I'm giving you that formula just in case you come up across something where it's difficult to do that on. Okay? All right, so let's go on. Now we're going to do the secant. So we'll kind of transition to that. Then what we start looking at is transformations. Okay? Okay, on a unit circle, okay, what's the cosine? Cosine is what?
X.
The x value. So let's go ahead and fill out this row right here for the cosine. Okay, like this. Starting with 0, the cosine of 0 is 1. Cosine of pi over 2 is 0, and so forth. Okay, you want to get that memorized and do that quickly and efficiently like that. Then everything just goes backwards since it's periodic. So basically this point right here would be the same as that. That point right there would be the same as that, and so forth. Okay, so once you learn that, you can just see how the 5 key points go. Okay, so that's a cosine wave. And then what we're going to do is something very similar. When you do a secant's 1 over cosine. So we know the secant of x is 1 over cosine x. So we do exactly like we did the cosecant. You do the reciprocal of that number. So that would be a 1. This would be 1 over 0. So that's undefined. This would be 1 over negative 1. So that's negative 1 and so forth. Okay, right? So everywhere that the cosine is 0, you're going to have undefined, and then just do 1 over this number. You can do that in your head. You don't have to write that down. Okay, so we get that. Okay, so just kind of like we did on the cosecant, it's exactly the same principle, but we're basing it on the cosine instead of the sine. Does that make sense? Okay. Now let's go ahead and let's do a graph of that. And what your goal on this kind of problem is, a problem at this level, you want to be able to do a quick graph without even having to look at the unit circle. That's kind of your ultimate goal. Okay, so let's go ahead and get this put together. And if you got the table filled out, you can go ahead and start graphing it. So again, in radians, get your x-axis put together. Okay, you got to label stuff. A lot of times students don't like doing that, but you have to. So we're going to go like that. And then we'll do the same thing. The y-axis just go to 1 and go to negative 1, and then have a little bit of room like that. Okay? Now, one of the things that you want to learn how to do is just memorize the cosine. Where does the cosine start? Well, it starts at 0, 1. If you remember that, then you can visualize how it's going to cycle. It goes there and goes down to the midpoint and to the minimum like that. So you should be able to graph a cosine very, very quickly and efficiently. So I'm just going to put these points on the cosine. Then I'll use a dashed line like that. And I'm going to label that the cosine. All right, so that's what we've worked on so far, is how to just do a basic cosine like that. Okay, now what we got to do is we got to figure out the asymptotes. If you look at your table of values, where were all those asymptotes? They were any place where you have a midpoint. So pi over 2, 3 pi over 2, negative pi over 2, 3 pi over 2. You want to go ahead and draw your vertical asymptotes through those places like that. Okay, that's just because you're doing the reciprocal of 0. So therefore, you're undefined there. So you want to go ahead and just kind of put the asymptotes in. And then we'll end up kind of answering some questions, and we'll find the equation of the asymptotes here in a second like that. Okay, so that's the setup. You get the cosine, you get the asymptotes, and now it's exactly the same as the last problem. You just draw these U-shapes. So you would take the high point like that, and then the low point. Just make sure you get close to the asymptotes, but don't touch it. And it would go like this, and so forth. Okay. Back when I was in Trig, way back a century ago, My teacher used to say this is a camel, the cosine's a camel, and the secant sets on the hump of the camel. So I still remember that. To this day, that's the camel's belly, so it's sagging from the belly. Okay, I still remember that teacher saying that. Okay, any questions about that? Okay, so if you got the cosine and the sine down, it's not hard to do the secant and cosecant. Okay, any questions? Okay, now let's answer some questions about this. Now this domain and asymptote, now I want to kind of look at this. So when you do the domain, it's going to be everywhere except these numbers. So the numbers that x cannot be equal to, I'm just going to write them down and we're going to look for a pattern. Negative 3 pi over 2, negative 1 pi over 2, I'm going to put a 1 there to emphasize that, 1 pi over 2, 3 pi over 2 like that. Okay, so what do you predict will come after 3 pi over 2? 5 pi over 2, 7 pi over 2, 9 pi over 2. What kind of numbers do I have in front of pi? I have odd integers. Now you have negatives, so you got to have integers. You wouldn't just say odd numbers, you have to say odd integers. So the way that you do this domain is like this. The number in front of pi is going to be the variable k. So you just say k pi over 2. And then that's going to change. That's going to be an odd integer. Does that make any sense? Okay. It's always got a pi over 2 in it, but it's got an odd number in front of pi. So what you say for your domain is you write this like this. And this is the only way you write it. You don't want to write this in interval notation. You say set of x, and you say x cannot be equal to k pi over 2, and you have to say k is an odd integer. Okay, I don't have a symbol for that, although I can show you one way to write that. The best way in this class to write it's like this. Also, 2k plus 1 is a way to write an odd number. I don't usually emphasize that in this class, so just write it out. Okay, like that. Okay? All right, look at the graph we just did. Does it have a minimum or a max? No, it doesn't have one. Okay, because it's the U shape we're talking about. Okay, how about the range? What does that range look like? Does the range look any different than the cosecant? Okay, it's the same. Okay, it's going to range from 1 to infinity. Remember, you're looking at y values and below negative 1. So negative infinity to negative 1, and then 1 to infinity like that. So it's the same. Okay, it's very similar to the cosecant graph. So on this, we'll just say interval notation, negative infinity, negative 1, bracket, union, 1 infinity like that. Okay? All right? Now the period, look at the period on this. Okay? So basically there's one way you can look at this is kind of like this. I'm going to start here because you'll see it easier. A period would be that right there. Okay? Because it would be a U shape that's pointing up and one that's pointing down. I just put these two together to make one, so what is that period going to be? 2 pi. So far 2 pi has been the case just about every time on every function we've done so far. So the period's 2 pi. Every time 2 pi goes by, you'll have the cycle, which is an asymptote, U going up, asymptote, U going down. That's the pattern that you see on that then. So that's 2 pi. Amplitude, we don't have one. Okay, does that make sense to everybody why we don't have an amplitude? Now, amplitude is the distance, half the distance from the max and min. If it doesn't have a max or min, then you can't have an amplitude. That's the idea, okay? So be careful about that. Okay, and then the vertical asymptotes go like this. So once you figure the domain out, it's the same idea. Now you would just tell me what x is equal to. So it's just like the domain. You would say x is k pi over 2, and you would say k is a odd integer. Okay, on the asymptote, you're telling me what x is. On the domain, you're telling me what x isn't. Does that make sense? Okay, so they're both the same idea. Okay, all right, so that's the basics. Okay, what I've done is a basic secant and a basic cosecant. And now what we're going to do is we're going to do transformations again. So we're going to teach you kind of how to plot these things out without doing anything with your calculator. I am going to do a little calculator stuff here as we go through this, but let's kind of do this to start with no calculator. Okay, so I've done the easy part. Now let's do these that are a little more complicated. So what you would want to do, and watch this really carefully because you want to be able to do this without a calculator, and if you follow this procedure, you'll generally be okay. if I want you to graph a cosecant, what you really should do is your total focus should be on graphing 2 sine of 2x. We're going to focus on graphing 2 sine of 2x. Okay, that only, and then once you have that, you'll figure out the asymptotes and you'll sketch in those U shapes. That's how you're going to go about doing that. Okay, now we learned how to do this before, so the period is a little different now. Okay, remember we did this in the last section. We said the period, if we have a formula, the period is equal to 2 pi over omega like that. Okay, in this problem, what's omega? It's 2. Okay, so that's what's changing the period. It's stretching it or shrinking it this way, like that. Okay, so what you're going to have there is you're going to have 2 pi over 2, so that's going to be pi. So that means the period's pi, and that's going to change how we do the x-axis. So you have to start that way. If you have a period change, find it. Okay. Now, the other thing we want to do, and I didn't write, let's down here, what we want to do is we get what I call the increment of the x-axis. And what you do is you divide that by 4. We talked about that last week a little bit. So take the period and divide it by 4. So the period's pi, divide by 4. What that means is when you do your x-axis, it's going to go by pi over 4. And you just count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, and that's how you get your x-axis when you put this together. Okay, phase shift, don't even worry about that. I shouldn't even put that there. We don't talk about that until section 7.8 anyway, so just ignore that. We're not even to the phase shift yet. Okay, amplitude, we don't have one. Now don't confuse that with the sine. The sine does have an amplitude of 2, but the cosecant doesn't because it doesn't have a min or max. Okay, now what I'm going to do next is we're going to go ahead and we're going to graph the sine wave, and we're just going to focus on the sine only, and then we'll sketch that in and figure out the rest. Okay, so watch I do this very carefully, because if you follow this strategy, then you can do these trig functions pretty easily. Okay, so first thing is the increment's pi over 4. What does that mean? It means that you're going to start with pi over 4, and then you're just going to count it out. Now you guys can do this in your head, and you don't have to write this out, but I'm showing you what I'm doing. I'm just counting 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so forth. Okay, and reduce the fractions, obviously, as you go. So that's going to be pi over 2. I want these in a reduced form. Then you have 3 pi over 4. And then 4 over 4, you have pi. What did we say the period was? Pi. See, that's important, too. Okay, when you get that increment, you need to count to 5. Starting there, 1, 2, 3, 4, 5. Those are your 5 key points. They're going to occur at those places right there. Okay? And we can do just one period of this. Now, if you can do one period, you should be able to do the others like that. Now, let's go ahead and take this back like this and just kind of repeat ourselves. We'll graph this through 2 periods like that. Okay? Now, you got to think about your y-axis. Okay? Look at this 2 on the sine. What is that going to tell you about the sine? Okay, it's going to amplitude change, right? So that means you need to be up at least 2 and down at least -2. So what I'd recommend is that you do something kind of like that. You got to have a little bit of room to draw the U shape like that. Okay? So we got that. Now we're ready to go. Now your goal on this problem is not to even look at the unit circle, just knowledge. Okay? Where does a basic simple sine start? What point? 0, 0. Get that in your head. So what I'm going to do on this now is I'm going to start there because I'm graphing the sine. Now the next one goes to the max, but since it has an amplitude of 2, where does it go? It hits a height of 2 now. Okay? Then it's going to cycle back down there, down to its minimum, and down like that. Okay? So you can do all that in your head. If you know the sine starts at 0, 0, and you know the amplitude's 2, then you just raise the max to 2. Okay? Then we're just going to kind of cycle that in like that. And that what we're doing right now is we're graphing 2 sine 2x. And then you just cycle back through these other points kind of like that. Okay, tell me if that makes sense, because I want to make sure everybody's gets to the ability where you can do that in your head. You don't need to do 5 graphs, and transfer each one. That's how you do 2 sine 2x. And the period change came from changing those x values. Okay, amplitude came from 2 like that. Okay, now tell me where you think the asymptotes would be.
0,
Right there, pi over 2, pi, and so forth, right? Okay, because that's where the value of the sine is 0. So if you take the reciprocal of 0, you get something that's undefined. So what you want to do next is you want to go ahead and put your asymptotes there. Okay, now these are what we call the midpoints. Don't think of them as x-intercepts, think of them as midpoints. So you just go through and sketch those in, kind of like that. Okay, the y-axis is an asymptote. And then we're ready to graph. So see, really all of our work on this problem, if you think about it, was graphing the sine. And then you can tell where your asymptotes are. Now you just sketch the rest. Okay, I don't care how accurate the u's are. I just want to make sure that you have touching the maximum. And then what you do from there is you just draw it towards the asymptotes, like that. So then you can just sketch the rest, like that. And just make sure that it doesn't touch the asymptote, you're showing that it's getting closer like that. Graph done. Okay, how's that look? Okay, kind of fun, isn't it? Okay,
Does it have to touch the point?
Yes, it does have to touch the point, because that is, remember the sine would be 1. The reciprocal of 1 is 1, so it does touch the point right there. So that's the only place it comes in contact with the 1, okay? Okay, so let's see, we're going to do the asymptotes on here also, and the domain, so let's kind of look at that. Now what you do on the asymptotes, I'm going to show you 2 things. What you always try to do as a student is find a pattern. Okay, so let's see if we can figure this out or not. There's going to be times when you will struggle mightily with seeing a pattern, so I'm going to give you a formula too that will always work. Okay, so let's just kind of write down what we have on these asymptotes. All right, and let's see if we see any kind of a pattern. Okay. Now, what I'm going to do on this is I'm going to do this like this. Now, you don't need to write this down. I'm doing this more for reference so that you'll see this better. At least I think you'll see it better. Okay, I'm going to write these down in an unreduced form. Then I'm going to highlight the ones where the asymptote is. And then we'll see if that's enough to do a pattern. Okay, I'm just writing this down just so that you can see this. Okay, so the asymptotes were here. They were at 0, there, 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 and there. Let's see if we see a pattern, okay, with the unreduced form. Well, they all have a pi over 4, right? What's the number in front? 2 pi, 4 pi, 6 pi. What kind of number do you have? You have an even pi now, right? Okay, so if you kind of look at not reducing it, then you'll see that easier. Okay, does that make sense to everybody? Okay. You always want to try to see a pattern. Now, I'm going to show you how you do with this in a formula in just a minute. So what you would do is you'd say your vertical asymptotes go like this. So we would say x equals k pi over 4. And then we'd have to state that k is an even integer like that. Okay, does that make sense? What would be the domain? That's what x can't be. What is something x can't be? K pi over 4. Okay, it's the same thing. Okay, so when you do the domain, what you want to do is you say set of x, and you say such that x is not equal to k pi over 4, with k as an even integer, like that. Okay, so that's the difference between vertical asymptotes. Like I said, you're saying what x is. Domain, you're saying what x isn't. Okay, does that make sense to everybody? Okay, now I want to show you one more thing before I do this next problem here. And I gave you on the previous page, I gave you a formula. So pay attention to this, because the formula will always give you your answer. Okay, so the formula for the vertical asymptotes is x equals the first vertical asymptote you find. And I could care less which one it is. Just try to find the smallest positive one. Plus half the period times k. I would write this down too. Half the period k where k is an integer. This formula always works. Okay, you okay over there? You getting your notes taken down over there? Okay, so what we're going to do is we're going to do this. Okay, let's pick an asymptote. Let's start with 0. Okay, that's an asymptote. If you have an asymptote of 0, start there. So you have x equals 0, then you say half the period. What did we find the period to be on this problem? That was pi, right? So we say half of pi times k, then we say k is an integer. Now that's a different looking answer than what I had you write down, but it will mathematically be the same. So you could say x is pi over 2k, where k is an integer, like this. Now, let me see if this makes any sense to you. If you count this out, now k is an integer. Okay, if k was 0, pi over 2 times 0 is 0, correct? Okay. If k is 1, what do you have? Pi over 2 times 1 is... Oh, shoot. Oh, no, we're good, we're good, we're good. So what's pi over 2? It's the same as 2 pi over 4, right? Now, k is 3. What do we have? We have 3 pi over 2.
3 pi over 6, right?
Oh, hold on. K is 2. I can't count. Okay, k is 2. So what do we have? 2 pi over 2. What's 2 pi over 2? Same thing as that. So it's the same answer. That's the idea is when you do that, that would just give you the reduced form of those things right there. So it's the same answer. Now, one thing that you want to do on this, because like on tests, I'm not kind enough to give you that formula, but I need to explain how you can remember this. Okay, it's really simple. Now just listen to this carefully. Okay, so the thing is, what happens in the middle of the period? What do you see in the middle of the period right there? You see an asymptote, right? So when you write this formula, you just say x equals the first asymptote plus half the period k. What does that half the period k do? It gives you the next asymptote. It's halfway in the middle of the period. Does that make any sense? You will always have an asymptote halfway in the middle. Okay, that's how I remember that. Okay? So you can either find the pattern or you can use that formula. I don't care which, they're both right. Okay? Okay, so let's do this next one here. Let's do a secant. Let's kind of see what we can get done on this one, and that'll get us through the secant, and cosecant, which is mainly what I wanted to do tonight. Okay, so let's finish up with this problem then. Okay, so what we're going to do on this one, don't worry about the factored form, we're not there yet. Okay, that has something to do with phase shift. Since it's a secant, what are you going to graph? Cosine. So you're going to graph the cosine of 2/3 x like that. Okay? You're not going to pay any attention yet. Okay, we're going to do that first of all. Then what we'll do in a transition here is we'll do those two things. Now you can do that whole graph in one step. If you do a little practice, you'll be able to do that okay. What I'm going to go ahead and do on this is I'm going to focus on graphing this for a minute. Then I'm going to focus on the negative and the +1 and how that works. Okay? All right? So here's how you start this. The period, the formula is 2 pi over omega, correct? Okay. What's omega in this problem, guys? It's that number right there. Okay, so what we have is 2 pi divided by 2/3. Okay, you got to multiply by the reciprocal, so that's 2 pi over 1 times 3 over 2. 2's cross out, so I have 3 pi. Okay, so this thing has widened out, okay, like that. Okay, the amplitude, you don't have one. And that's because we're doing a secant, but on the cosine, what's the amplitude? What's in front of the cosine? 1. Okay, the cosine has an amplitude of 1, but not the secant, okay? All right, phase shift, don't worry about that. I don't know why I put there. I shouldn't even done that. So just pretend like it's not there, okay? All right, now we do this thing we call the increment, okay? And this always works this way. This is super important on these problems. Once you get the period, you divide it by 4, and that will tell you how to break up your x-axis. So the period is 3 pi. Divide that by 4. So 3 pi over 4 is going to be how we increment the x-axis. Okay, like that. Okay? So is everybody with me on how I found the period and the increment? Okay, that's very big, okay? Now we'll start getting our graph put together here. Okay, now what I'm going to do on this is I'm going to write out these increments right here. Okay, so, and you don't have to write this out. You can just pay attention to this if you want to. I count by the numerator. I see students do that wrong all the time. So it would be 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. But isn't 12 pi over 4 3 pi? Is there anything significant in this problem about 3 pi? It's the period, exactly. So if you start at 0, 1, 2, 3, 4, 5, you have 5 key points. So when you get to that end thing right there, that should define what the period is. So what you want to do is let's go ahead and get this set up. Okay, and this time I'm just going to do 1 period. Okay, so I'm going to write that as 3 pi over 4. See, this thing is really 3 pi over 2. Okay, then this one is 9 pi over 4. And then 12 pi over 4 is really 3 pi. So whenever you do that in a reduced form. Okay? All right, now, if you look at the cosine had an amplitude of 1. So that's how you want to set up. And we're only going to work with those 5 key points when we do that. Okay? Now, what I'm going to do this is I'm going to do this in stages. So watch very carefully and tell me if you don't follow something. So I'm going to start with y equals cosine of 2/3 x. I would want a student to do that, not even look at the unit circle. Okay, where does a cosine start? Tell me that. Right there. Okay, starts high, right? Then it goes there, then it goes there, there, and there. Okay, so we're just going to pencil those things in very lightly. We're just going to graph that. Okay, that's kind of stage 1. Okay, like that. Then we're going to do the transformations like this. So the next step I'm going to do is we're going to graph y equals negative cosine 2/3 x plus 1. That's ultimately, if you look at the problem, that's ultimately what we're trying to do. Okay? Now, let's see if we got this. You got to do this in order. What does that negative do? Yes, okay, it changes the y value, right? Very good. So that changes that down there. What does the plus 1 do? Moves it up 1. Okay, like this. Now, you can do those transformations in your head, or you can even do this if you want to. So if you just do negative, and then take the y value, which is 1, plus 1, that's what you work out. So that would be negative 1 plus 1. That is now at 0. All you're doing is just taking the opposite of what y is, and then adding 1 to it. If you go to the next point, you go like this. A negative of that y value plus 1, so that takes you up to 1 like that. Okay? It doesn't reflect. If you're on the x-axis, you don't reflect. Now do this one like this if you want to. Okay, that would reflect to there, then where would it go? Up to 2. Okay? Now once you get the pattern, you're going to be in great shape. Okay? Or you can do, oh, battery's about dead. Okay? Let's see if I can luck out and finish class. Okay, so that point would go like that. Then this point would go like this, and so forth. Okay? Then let's lightly dash that in, and then we're going to complete our graph. Okay, like that. You guys follow those transformations. Okay? Remember, it reflected, then moved up 1. Okay, like that. Or you can do the arithmetic. Okay, tell me where the asymptotes are. Midpoints. 3 pi over 4, 9 pi over 4. Okay, it's midpoints. Okay, it's not x-intercepts. That's what students think a lot of times. It's those midpoints. So what you're going to do to get your final graph is you're going to go like this. So you just go ahead and put an asymptote there, then an asymptote there, and then we're in business. Okay, we got a graph. Okay, and then I'm going to finish up with the equations of the asymptotes. So you'd have a shape like that, have part of a shape like that, and part of a shape like that. Okay, so everything has been transformed. Now, what I'm going to do to finish this up here is the vertical asymptote. Let's do this. So what you say is x equals, just pick your first asymptote, plus 1/2 the period k. You can always use this formula if you want to, and k is going to be an integer. Okay, so here's what I'm going to do. What's the first asymptote? That is 3 pi over 4. Okay, what was the period? That was 3 pi, right? Okay, so we just say 1/2 of the period. The period was 3 pi. And then we have k, and then k is an integer. So you would want to clean that up kind of by writing this like this. You would say x equals the first asymptote, and then just write this as 3 pi over 2k, and you can use that abbreviation like I showed you if you want to do that. So you're probably fine on this one.